Hello everyone. Before diving into today's topic, we want to take a moment to thank you for your support. Every like, comment, and subscription really makes a difference and helps this channel grow. If you enjoy our content and don't want to miss future videos, subscribe to the channel and activate the bell to receive all notifications. The universe will continue to exist even after every trace of our civilization has vanished. When the last human being exhales their final breath, when every city has been swallowed by time and nature, when our names are forgotten and our works reduced to dust, the universe won't even notice our absence. It will carry on undisturbed, indifferent, in its silent march through eternity. This means we will miss out on cosmic events of such immense scale that they're almost inconceivable. But even if we won't be here to witness them, we can still mentally project ourselves into that infinite future and imagine what the billions, trillions, quadrillions of years to come might hold. We can observe, with our minds, what the universe will reveal when nothing of us remains. So let's begin this long journey through time. In relatively near timescales, from a cosmic perspective, one of the most iconic spectacles of our solar system will disappear: Jupiter's Great Red Spot. This immense storm, larger than Earth itself, has been raging in Jupiter's atmosphere for at least 2 centuries, perhaps much longer. It's a colossal vortex with winds reaching 1,000 kilometers per hour, a constant fury that defies earthly understanding of storms. Once, in the 19th century, it was even more vast, 4 times the size of our planet. But over time, it has gradually shrunk. Scientists believe that within a few centuries, perhaps even just a few decades, it may vanish completely. A phenomenon that has fascinated humanity for generations will dissolve into nothingness, leaving behind only data, images, and memories in our databases. When this happens, humanity may already be gone. But looking back at Earth, our own planet will undergo slow but relentless transformations. Around the year 50,000, we'll likely enter a new ice age. Currently, we are in an interglacial period, a brief intermission of relatively mild climate between 2 glacial eras. When this pause ends, global temperatures will begin to drop inexorably. Ice sheets will expand, covering vast areas of North America, Northern Europe, and Asia. Immense glaciers will stretch for thousands of kilometers, trapping huge amounts of water and lowering global sea levels by as much as 100 meters. Regions once fertile will become inhospitable. Ecosystems will migrate toward the equator, while humanity, if it still exists, will be forced to move in search of warmth, resources, and survival. Agriculture will become increasingly difficult, freshwater resources ever scarcer, and the struggle for survival will intensify. However, this fate is not necessarily inevitable. Human-induced global warming might alter this natural cycle. Some scientists suggest that climate change caused by greenhouse gas emissions could delay the next ice age, or even prevent it entirely. But at what cost? And how long can this unstable balance last? Even if we manage to avoid the coming freeze, other challenges await our planet. In about 100 million years, Antarctica, today synonymous with eternal ice, could return to being a green tropical oasis. It may sound like science fiction, but it has already been so in the past. In a distant time, Antarctica wasn't confined to the South Pole. It was a lush continent with forests, rivers, and rich fauna. It had a climate similar to today's Italy. But over tens of millions of years, the continent slowly drifted south due to continental drift, gradually cooling. About 34 million years ago, it reached its current position and global temperatures dropped, allowing for the formation of a massive ice sheet. If global warming continues on a geological scale, with a significant increase in atmospheric CO, the ice sheet might start to melt. And over millions of years, the continent could begin to drift again, perhaps northward. If the entire Antarctic ice sheet were to melt, global sea levels would rise by over 60 meters, submerging coastal cities, plains, and entire nations. An event that would completely rewrite the geography of the planet. But we won't need to wait for Antarctica to move to witness the birth of new worlds. In about 250 million years, all of Earth's continents will once again merge to form a new supercontinent, Pangaea Ultima. This cycle of continental aggregation and fragmentation has repeated for billions of years, like a slow geological breath. Australia will approach China, the Americas will join Africa, and the latter will be compressed against Europe and Asia. The collision will generate new mountain ranges, possibly higher than the Himalayas, and will deeply alter the planet's climate. Some studies suggest that the formation of the new supercontinent will lead to extreme climate conditions, with average temperatures exceeding 40 or even 50 degrees Celsius. The atmosphere will be saturated with carbon dioxide due to massive volcanism linked to active tectonics. The heat and humidity will make survival difficult for many life forms, especially mammals. Looking even further ahead, over the next billion years, the Sun, our source of life, will begin an irreversible change. It will become increasingly luminous, increasing its radiation output by 10% every billion years. This small increase will have devastating consequences. Earth's temperatures will rise enough to trigger a runaway greenhouse effect. The seas will evaporate, photosynthesis will cease, oxygen levels will drastically decrease, and life will become unsustainable. All living forms, from the simplest plants to the most complex animals, will go extinct. The atmosphere will become a toxic mix of gases. Earth, now dehydrated and scorched, will become a dry, incandescent rock. According to these predictions, we have about 3 billion years left to leave the planet before it becomes completely uninhabitable. But there is hope. We have already discovered over 5,000 exoplanets, some of which are potentially habitable. Over the next billions of years, we might develop technologies capable of taking us to new worlds. Humanity could become a multi-planetary, even multi-stellar, species, capable of colonizing planets with better conditions than Earth. Some planets may have immense rings, 100 times larger than Saturn's. Others might host vegetation in never-before-seen colors, like red or purple, due to pigments different from chlorophyll. Some may have ideal atmospheres, temperate climates, optimal gravity, true paradises for the evolution of new civilizations. If we persevere, the universe will offer us unimaginable refuges and possibilities. However, beyond these hopes, a quieter fate awaits us. In 1 trillion years, the universe will enter a new epoch, the era of darkness. The stars will have exhausted their fuel. The luminous giants that lit up the cosmos will go out one by one. The last stars will be tiny red dwarfs, incredibly long-lived, capable of shining for 10 trillion years. But even they will eventually fade. With no more light or heat, the cosmos will go dark. Only the remnants of stars will remain. Black holes, neutron stars, white dwarfs, and, eventually, black dwarfs. The latter, final stages of white dwarfs, will be completely cold, black as ink, silent. As of now, no black dwarf exists yet, because the universe is still too young. But in an inconceivably distant future, they will become the only remnants of stars. Meanwhile, black holes will dominate the cosmic landscape. Over time, they will absorb everything around them. Black dwarfs, neutron stars, residual gas. Forming structures called zombie galaxies, galaxies made only of black holes, orbiting around a central supermassive black hole. These galaxies will be dark, silent, cold. A ghostly echo of what the universe once was, teeming with life and light. Finally, even black holes will evaporate, slowly, through Hawking radiation. A process extremely slow, but inexorable. When the last black hole vanishes, the universe will be completely devoid of usable energy. Even protons might decay, according to some theories. Everything will be reduced to elementary particles scattered through the void, at temperatures near absolute zero. No light, no life, no motion, only eternal silence. But perhaps this won't be the end. Perhaps from that silence, something new will emerge. Perhaps time itself will be reborn. But that is another story.